Hey, Formal Topics people, here's the deal. I wanted a few more examples of what are known as nonlinear system of equations. We did a few in class, but I wanted to just give you a couple more examples to have while you're working through some of this assignment, just so you can refer to it. So here's the deal. I'm just going to quickly work through this, so pause the video whenever you need if you're going to be taking notes. So here we go. I'm going to do this with substitution. There's a couple ways we could do this. We could just substitute this guy into this. Or we can, solve for one of these and then substitute it in there. But because this is already a y equals, I'm just going to go ahead and substitute that into the x minus y equals -1. So here we go. So I'm going to go x minus, instead of writing the y, I'll replace it. That's the substitution part. The x squared plus 1, making sure I do it with a parenthesis because of this minus out front. I'm going to make sure that I distribute that minus. And then I have that written down like that. Okay, so now I have an equation to solve for x. Here we go. So x minus x squared minus 1 with the distribution. I'm going to reorder some things the moment I see that this is going to be a factoring problem because of, all the different types of x. So I'm going to reorder it like this. And then last but not least, I am going to go ahead and add this one over. So it's going to be negative x squared because, again, I got to get it equal to 0 for a factoring problem. And now I have a two-term factoring problem. So the two-term factoring problem, not a Japanese method problem. It's just going to be a factor out problem. Both of these terms have an x, so I'm going to factor out an x. So x, this divided by x is going to give you -1x. Or negative x, and then x divided by x is just going to give you a +1. There's a couple ways you could have done this. I could have also factored out a -x. It's honestly however you want to play it. Either way, once you factor this, you can set both of these equal to 0, so x equals 0, then -x plus 1 equal to 0. Subtract 1, divide by -1 or times by -1, and you're going to get x equals 1. So here are my two x values. Now I just need to add those in to either of those two equations to get my y values that go with it. I'm going to pick this one that already obviously has y by itself, so here we go. So I'm going to do y equals x squared, but this time I'm going to be plugging 0 in. And then I'm going to also do y equals x squared, but again plug in the 1 plus 1. So 0 squared plus 1, that's just going to be 1. So there is my first ordered pair. I plugged in the 0 I got and got 1. So 0 comma 1, x comma y, there's my first intercept. That's the way I want you to show your work or show your answer. And then when I plug in 1, I get 1 squared, which is 1 plus 1 is 2. So I plug 1 in, get 2. There's my other ordered pair, so 1 comma 2. So here's an example of a non-linear system of equations. The reason I know it's non-linear is because I definitely got more than one answer. Okay, so there's example number 1 for you. And let's just go on to example number 2. Okay, this one definitely looks pretty weird because of, all this other, usually don't see like an x times y kind of situation. So what I am going to do is think about how am I going to do this. Now, elimination wouldn't work because this is an xy term. I don't see any xy's here. Also, these have x squareds and stuff, so probably don't want to do that. Now, if it's going to be substitution, I need to get one of these variables by itself. Now, I know some of you might say, well, I could get this y squared by itself and then, divide it or square root it, right? But that's going to create a plus minus, all this other stuff. I don't think that's a good idea. So what I'm going to do is I'm actually going to use this equation here. And I'm going to get, let's do y by itself. And the way I'm going to do that is by dividing x on both sides. Okay, so the x's cancel here, and I get y equals 4 over x. All right, so this would be the equation that I'm going to use to substitute into the other equation. The reason why I want to do that, I know, yes, there will be a fraction, but good news is I know how to get rid of fractions, 1, but 2, I didn't have to do this whole square root thing with the plus minuses. That just makes me a little nervous. So that's the way or reason I chose this strategically. So I'm going to plug in 4 over x and for y, so it's going to look like this, x squared plus 4 over x squared, because that's the swap for y. equals 8. Here we go. So x squared, really unchanged. When I square 4 over x, that's a 4 over x times a 4 over x. That would actually end up getting me 16 over x squared equals 8. Now, problem being, again, cannot, I repeat, cannot have fractions whatsoever. So I'm going to actually have to get all of these guys to have an x squared on the bottom because one of them does. So I'm going to multiply this guy by x squared over x squared because, again, I'm going to make them all x squared because that's the only denominator there is anyway. Multiply this guy by x squared over x squared. And x squared times x squared, that's x times x times x times x, would be x to the 4th over x squared plus 16 over x squared. That one doesn't need anything because it's already, and then 8x squared over x squared. So lots of x squareds here. I'm going to multiply both sides now by the denominator, get rid of that. So that's going to leave me with x to the 4th plus 16 equals 8x squared. Again, I know this is a factoring problem because the fact that there is multiple types of x's, and I know from like the last quiz and some of the other previous homework assignments that this is a 3-term one, not a normal 3-term one, but it's definitely a 3-term one that I can go ahead and do. So I'm going to move this over to the other side because, again, even though it's a factoring problem, I still got to get it equal to 0. And I'm going to put it in the right order, meaning I'm going to put the x with the biggest amount of variables, then the next amount of variables, then usually the one with the number on the right. So because I'm subtracting 8x squared over, it's going to be negative 8x squared plus 16 equals 0. So Japanese method, because there's 3 terms, I'm going to write x to the 4th, make my table here, and 16, right? Breaking up x to the 4th, one way to do that is x squared times x squared. That would probably be the best way to do it. And then 2 things that multiply to get 16, and then I'm thinking to get 8. I'm going to go with 4 and 4, and because this is a negative term, I'm going to make both of these negative, okay? That way, when I multiply negative times negative, it's still positive, but I know I'll be able to get that middle term negative, right? So to check this, I'm going to crisscross it, right? So that's x squared times negative 4, so that's negative 4x times a negative 4x. Sorry, negative 4x squared, and then another negative 4x squared. So it's negative 4x squared minus negative 4x squared, which again gets you the negative 8x squared. So I am good, okay? So writing the factors, this one and then this one. So it's going to be x squared minus 4, and then x squared minus 4 equals 0, okay? These are actually the same thing, so I'm going to set them both equal to 0, but they are going to give me the same result. So I won't have to use both results. I only have to do one of them because it's the same thing. So I'm going to add 4 to the other side, because I'm just trying to get x by itself here. Square root, and I'm going to get x equals the square root of 4, but because I am undoing a square, I'm going to need to do a plus minus the square root of 4, which is, square root of 4 is 2. So this is my answer. I would do this one, but it's going to give me the same thing, which is just repeat answers. So I have 2 answers here, x equals 2 and x equals negative 2 for x, okay? Now I need to go plugging in to my equation up here, right? So here's my equation up here. I need to plug in 4x so I can get my y's. So here we go. So I got, let's see here. Y equals, it's 4 over x, so I'm going to do 4 over 2 in this case because that's what my x is. 4 divided by 2 is 2. So one of my intersection points is going to be 2, comma 2. And then for my other one, same idea. I'm going to use this equation, y equals 4 over x. But instead of the x, I'm going to put this time negative 2. So 4 divided by negative 2, that is going to be what? Negative 2, right? So y equals negative 2. So negative 2 and then negative 2. So that would be my other intersection point, okay? Now the only thing you do have to worry about, again, is any kind of, Problem with the denominator with a variable, right? So for instance, I did make a fraction with an x in the bottom, right? So I would have to make sure that this doesn't create any zeros. But luckily, when I look at my x values, right, when I plug them in, that didn't happen, right? If that were to have happened, then obviously that's a problem. But these are the legit answers, so I'm done with that problem. Okay. So there is a pretty complicated example of a nonlinear systems. All right, I got one more for you. So I'm looking at this problem, and this looks pretty hard, especially with this idea that if I were to try to get x or y by itself, I would have to, again, square root, and that creates all these other problems. So I am thinking that I am going to have to not use substitution this time. Luckily, if you look at everything and everything's kind of like lined up, right? I'm thinking elimination might work. So thinking back to, the elimination you do for your regular problems, right? I'm just thinking of the coefficients, right? I just need them to be opposites. And I think what I'll do is I think I want to eliminate the y's because right now this is technically like a -1, right? If I were to multiply this by -2, this bottom one, that would make my y squareds opposites. So I'm going to do that real quick. So I'm going to multiply this times -2. I'm going to leave this one the same, right? So I'll rewrite the top one because I really don't want to play with it much. I like it the way it is. I'm going to multiply, a -2 into each of these, so it's going to be -4. X squared. This is going to become a positive 2y squared, which is why I liked it, because that makes the y squared is opposite. And then -2 times -2, which gives me 4. Now, when I go to add it together, because that's what I do in elimination, just add it straight down, right? I get 3x squared minus 4x squared, so that would be just a negative x squared, or -1x squared. These would cancel, right? And I would be left with this equals, -5 plus 4, which is -1, okay? So, not a bad problem at this point, because what I'm going to do is I'm going to divide by -1 first, and then I'm going to get x equals +1, because, negative divided negative is positive. And now I'm going to go ahead and square root, and the square root of 1 is 1, but because, again, I'm undoing a square, in algebra, I'm going to have to put a plus minus in front of it, okay? So there are my two answers for x, okay? So here is the dealio. I'm going to pick one of these two equations to plug it back in to get my y. I'm just going to use the top one, because why not? And I'm going to start with just plugging the +1 in. So I'm going to do 3. It would be normally x squared, but I'm going to do 1. Minus 2y squared equals -5. So I'm going to see what happens, what I get when I plug a 1 in, see what I get for my y. So 1 squared, doing order of operations correctly, is going to be 1 times 3 is 3. Minus 2y squared equals -5. I'm going to subtract 3 to the other side, and that's going to make that -8. I'm going to divide by -2. That's going to turn this into a +4. And then I'm going to go ahead and square root, and I'm going to get y equals plus or minus the square root of 2. Square root of 4, which is equal to 2. Now, what's really weird about this is I plugged in a 1, and I actually got 2 answers. What that would mean is that means there are actually 2 intercepts, 2 intersection points for this system of equations at x equals 1. So 1 gives me a 2, but 1 also gives me a -2. The way I'm going to show my work here, in coordinate point form at least, is the following. I'm going to go, and I'm going to put my coordinates down here. It's going to be 1 got me 2, but 1 also got me -2. So technically I have 2 points there, and I haven't even plugged in the -1 into this, right? So I'm going to do that one next. So I'm going to do 3 -1 squared minus 2y squared equals -5. -1 squared is +1 times 3 is 3 equals -5. Subtract 3. This is going to look like a very similar problem at this point. Divide by -2. Square root. We get y equals plus or minus the square root of 4, which is 2. So similar result, but notice how I did plug in a different number, right? So -1 rather than 1. So -1, this is the way I'm going to write these as points, is -1 got me 2, and -1 also got me a -2, okay? So technically, this answer, these two equations, if you graph it, and technically these two equations are ovals, they actually run into each other 4 times, here, 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 and here. So those are 3 examples just to help you out with the assignment a little bit. Hopefully that helps. Obviously, if you have any question on the assignment, either email me or we can talk in class. Okay? You guys have a great day. All right, bye.